we're going to start the lecture. You guys can continue on with the quiz later when we have lab. So today, you guys did the quiz, we're going to do the lecture, we're going to have a lab, which you'll do some SQL stuff.
Okay.
In announcements, we're going to have the final project specifications up later on this week. So you can get started on that as soon as possible. Alright, so as you know, today we're talking about databases. And we want to figure out, we want to know how databases fit in with the web development world. So what we've already talked about is HTML, CSS, and JavaScript, and that's all client-side code, right? That's stuff that you send to the client, and the client browser interprets it and renders images or text or whatever. And on the server side, what we have is PHP, which Amber talked about last week, and what that does is allows us to get requests from users and create dynamic responses so that we can have things personalized, right? So, for example, when you're able to, in the Twitter project, you're able to submit like your name and message and send it to the server, and the server was able to respond back with like extra messages or something along those lines. So that's what PHP allows you to do. And the way databases fits in is it allows us to be able to store those messages. In the example of our mini project 3, databases will keep track of all the data and allow us to access and update and retrieve those elements. So for this course, we're going to be talking about MySQL, which is the software that's the database that we typically use ourselves. And it's just one of the many brands of databases available out there. And I'll get to the other types of databases and brands in the next slide. So what MySQL is a relational database management system, RDMS. It's kind of a mouthful of words. But what that means is that it allows us to take elements and sort of organize them in a way so that we can create relations among those items. So we can sort of model classes, for example, where you have like a class ID, a course control number, and you have the number of students, and you can put that in the table and relate that to a students table, where the students would have courses that they're taking in the semester that they're taking, and so on and so forth. And with those sort of two tables, you'd be able to link them together and create a relation between the courses and the students. Interesting fact, MySQL is named after the developer's daughter named Mai. Thank you. So yeah, like we said, we use this a lot with PHP, and that's partially the reason why it's so successful. Okay, other database management systems. So there are many other database management systems. We already talked about MySQL. There's also something called Postgres SQL or Postgres SQL, SQLite, and Microsoft SQL Server, which is also very popular. And what we can notice from each of these brands is that they all contain the word SQL. SQL stands for SQL Structured Query Language. And it's just sort of a way for us to talk to databases, talk to tables, and relate them together. And yeah, as you can see, SQL is pronounced sequel, like the sequel to a movie. So we already talked about how databases fit in, and this is just an example of Google Maps, but how they're able to sort of, in the back end, store a bunch of data, for example, images, streets, names of the streets, and so on and so forth, and locations. And all that is stored in a database, and on top of that, they have some kind of framework. Probably for Google's case, it's not PHP, it's something else, but you could imagine writing a PHP framework on top of that to access these things and sort of render this, this Google map through those two technologies. So the way databases fits in terms of like time and space is you first have a client and you talk to the internet, and the internet connects you to the server. One of the most famous servers, in case we didn't talk about it, is Apache servers, and they typically serve like a ton of things like PHP, for example. Apache servers are very popular with PHP. And what the Apache server does is it's able to talk to a MySQL database, and it accesses data to and from there. So more specifically, we have an example here. If you like open this URL, what happens is you first contact the server. The browser says, okay, we're going to go to this URL. We're going to contact the domain, and that domain is going to talk to a PHP page. And the PHP page gets rendered by a PHP interpreter, and it generates some HTML, generates some database calls, or whatever you have in the PHP code. So in many cases, though, in a decently complicated PHP page, you have to access like file systems. For example, maybe you're grabbing images from like your public/images folder on your server, or you're talking to databases, in which case you create a connection with the database, and you would start querying that database on whatever you want. And the database will return some results back to you, and with those results you can do some more programming to sort of retrieve those results, parse them out, and feed them to the client, which happens in the response back in HTML. So more use cases for databases. One such is directory services, like I talked about, how you can create tables to relate students and classes and even faculty. User authentication, the way you're able to log into a site is to keep track of your passwords, your username, your email, all your credentials. But just an interesting side note though, the way they store passwords is sort of in an encrypted way. So there's, for a legitimate site that's well secured, they don't actually store your passwords in plain text. Meaning, if your password is ASDF, you wouldn't see that in the database if you try to query your login name. What you'd see is some seemingly random string of characters which are generated through certain algorithms that they use from a library. So it's also used in banking, reservations, browser cache. Browser cache is actually an interesting example because databases can at times store commonly hit pages so that they don't have to continually render for example, a particular PHP page if everyone goes to it. So it sort of takes off some load from the server so that it doesn't have to do so much computation.
Has there ever been a case where someone has like broken into a database and like tried to figure out the algorithm and like obtain passwords?
That's people have tried. For insecure systems, that's definitely happened, and they've been successful. Hackers have been successful at doing that. But right now, if you follow like proper security procedures, what I mean by that is there's like a certain guidelines in which you use like these known cryptographic algorithms that can sort of mix up the passwords in a way that's like it's actually like so far impossible to reverse.
Okay.
So they've been able to use those sort of standard library functions, and it's like basically a lot of math, and I personally don't understand it. All I know is that you call some library function that sends it to this hash function, and it just spits out some random string, and that's the password.
Okay.
Yeah. Is everyone else good? Questions? Okay. Like I said, SQL stands for SQL Query Language. And we can, obviously do a lot of things with databases. We can talk to them, ask them about for the example of the students and courses database, you can ask them like how many students are enrolled in the particular class, what's their average attendance, how many assignments they turned in, what kind of grades they have, and all this can be done very organized in a very organized way by using databases. And we're going to talk about this in a little bit, but the way you sort of interface with the database is you do a series of several calls, which is like either create, where you create some row in the table, or you read a table in the value, or you update the values in the row of the table, or you delete them. And if you sort of look at the first letters of every word, it stands for CRUD, and CRUD is like the typical thing that's used to describe the interactions between yourself and the database system. So, more specifics, CRUD. So, we first start with a create sort of command, and what a create does is it allows us to create a new row in a table. If it's not very clear, you can think of databases as just a series of a ton of Excel spreadsheets. But the difference between an Excel spreadsheet and a database is that the database allows you to interconnect multiple spreadsheets together based on some common elements that they have among them. And I'm going to give you some pretty good examples in a little bit. But just to sort of prime you for what you're about to get a taste of, we have creates which allow you to insert rows into the table. And in this case, we're going to insert a row into the products table where we're going to specify a name and a price. And in this case, the values of the name and price are Tonka and $13. In a read, what that allows us to do is just query the database and grab information without altering any of the contents. So, and that works by having what you call a select statement. And it selects a table. In this case, it's two tables, an index table and a name table. Oh, I'm sorry. It selects two columns, an index column and a name column from the products table. And update is also very similar. Except that you have update, you specify the table and these values with a condition where name is equal to Tonka truck. Delete is also very similar. You delete from a table where some condition is met. So, like I said before, the way data is stored in databases is very similar to the way you come up with Excel spreadsheets. You have columns with column headings, and then you have rows. Each row in a database table is representative of a particular value. So in the first row, we have something called PID, which in this case is short for product ID. And we have the name of the product and the price of the product, and the same thing for the next two. An interesting thing to note is also that you have to specify when creating this table what type of values these cells can contain. So this column, the PID, can only have an integer value. The name can only have a varchar, which is a variable character, basically meaning that any characters like punctuation marks, numbers, letters, so on and so forth. And then you have a decimal for the price column. Oops. And one characteristic of a database table is that you have an ID which all have unique numbers. And what this column is, in terminology-wise, it's called a primary key, and it's always unique in a table, meaning that you can't have a second row with the PID 1.